Okay, so today we are going to start about our database. So let me share the screen as well. So let me know once you are able to see the screen. Okay, so today we are going to start our database migration. So in the database, there is many case studies are available online. Here we will also cover up, one of the case study which and Samsung did. So, Samsung has a very big database. So just hold it. Okay, so let's start directly. So Samsung, what are the is the largest company by revenue and flagship company of Samsung, world largest manufacturer of mobile phones, major manufacturer of numerous other electronics. So they have a one of the biggest database migration. So they have the Oracle-based architecture was harder to update. It was monolithic application scaling without time had become risky and costly. So they have the many applications like monolithic application where they were using the database. So difficulty in scaling the user and services, the volume traffic getting created. So generally you are thinking about how there is a many application of the Samsung. For example, Samsung Health, Samsung Cloud itself is there. There is many Samsung password. So many Samsung applications are there which is available on your mobile as well. Then change that services, right, or increase that scaling based on because number of user every year is increasing on Samsung. So need of new technology, microservices, and need of new technology and microservices architecture cover upcoming traffic from their Samsung devices and services. Hi GP. So we just started. Is the first slide. Yeah. So this is the first slide, only the migration. So no worries. So we are just uh, started. So ease in the migration. So we are talking about the Samsung migration. So Samsung did a one of the database migration. So that case study we are talking about here. So even we can see here as well in the browser. Let me show you. So this was the case study. So what were the problems? So moving from monolithic to microservices. So they want to move everything from a monolithic application to microservices. I hope so you know about the monolithic. If you're not aware, monolithic is just like earlier days. Everything come under the single system, you can say. Okay, front end, back end, they are tightly coupled with each other. If one service is down, for example, database is down, your front end, back end, nothing will work. So right now, what happened these days? What is in a simple way? What is microservice? If, for example, you are logging to the Amazon or AWS anywhere, think about you are doing the shopping on Amazon. You complete your shopping and their payment system is not working. Now Amazon website is working. You can log in, you can pick all the items which you want to buy, you can add into cart. So these are all the different services. Cart is the different service, front end is the different service. There is a multiple categories are there, that is different service. Now you are coming on to the payment. In the payment, if there is a credit card section is not working, but um, net banking or wallet that is working, it means different services are there. So if one service is down, other services will not be impacted. That's why microservices come into the picture. Okay, so they want to move from monolithic to microservices. So easing the great migration with the AWS migration service. So what they did from Samsung, one of the Aurora most attractive feature, 85 to 90% of the Postgres queries in SQL match with the existing Oracle queries. This is the big thing. See, they are saying the Oracle is famous for their query time. If your query means big queries, not the small one, like you have the terabyte of data and you have the query is complex. For example, you are the Walmart, or you are the one of the biggest multiple shops you have. Now the you are the query, okay, in my Bangalore, okay, showroom, Samsung mobile, this model, okay, how many we sold it or how much we have in the stock. So such things, when you query it, there is a terabyte of data. They have the might be hundred of stores. In hundred of stores, you have to find only one store. In one store, lakhs of items are there, right? So from that million of items, you will find one particular item. So it's a big query, right? So for such, they are saying 80 to 85% of the query in PostgreSQL is matched with the existing Oracle queries. So if 85 to 90% is matching, sometimes companies saying, okay, 5-10% we are okay to manage that. So they moved their Oracle database to PostgreSQL on Aurora. So it took just 22 weeks. In 22 weeks, this work streamlined the experience of the Samsung and customers, and it look at a more opportunity in the cloud. So how it is happened? Scale up to 15 Aurora replicas it's created there. And within 22 weeks, 4 terabyte was migrated to Aurora. Samsung completed the whole process within 18 months. Now, what is the whole process? How it is 18 months is you think about big time? No, 18 months is not a big time, because when the this big company's terabyte of data is there, you can't take the decision in a day. You will go for the POC. You will firstly contract will sign, then you will go with the POC. You give the requirement. Yes, I need these many applications are there who is using. So in this application, I need this much query time. It is there. If this query time will not come, my application will fail. So all requirement gathering session will be happen, and then they will start for the migration. Benefit of AWS Aurora enables 60 millisecond latency or less 90% of the time, reduce monthly database cost by 44%. This is the monthly cost, and all over if you see here, they mention clearly here, reduced 44%. So 44% is huge. For example, their database cost is 1 million, it is now half million, and companies saving a lot. Samsung transformed the monolithic database architecture into faster and more effective solution that streamline services for both staff and end users. So as per their, so that is they migrated into the faster and cost-effective solutions in their monolithic database architecture. So now this will help them to increase their more users on their application. Now, from here we will start about what is the database migration. Okay, so what is the database migration? It is process of transferring one or more source databases to one or more target databases. Sources can be your local system or cloud target, vice versa. See, as simple as that. If you are onto the even cloud, okay, so simple thing, you have already have database. Now this database is running on anything. So this database is your Oracle, or it is Oracle, or you have the MySQL. So it can be anything. Now, migration is always you are migrating this one to some other database. Now, it can be Oracle to Oracle migration. Might be it is Oracle to Postgres as SQL. Okay, it can be MySQL. So it depend upon what the migration you want to do. It is changing from one database to another database. Okay, it's always called the migration. Source to destination or source to target. AWS database migration challenges. Following are the challenges that occur during the database migration. Firstly, identify and prioritizing the database migration. You have to find out what is your database. you have to prioritize under that database how many databases are there, how what is the priority for that database. It is very critical. It is for development, it is for production, it is for finance. For example, if it is a net banking database where all users accounts their money is mentioned, trading data, that is too critical. Okay, any company's finance data. Then migration of large database in terabytes to and petabytes. Then you have to see how much big it is. It is terabyte of data, petabyte of data. So how you want to live migration with zero data loss. So this is very important because in database uh, nobody wants any data loss. Any single query, single record should not be missed. It should be exactly same. Then the two major challenges, source migration and secured database migration. Sorry, schema migration. What is schema? So every database they have a schema. So they have their records, which particular schema, how the tree architecture that is in the database. Now, if it is Oracle, Oracle has a different schema. Postgres has a different schema. So to migrate, firstly, schema is a big challenge. Then database is the second. Then securely manage because it is going on to the cloud and many people still has a concern if it is on the cloud, if our database is exposed to the internet, then what will happen? And it happened as well earlier because by default you can means your database can be publicly available. If it is available over the internet or you can make it public by mistake, so then it will be publicly anybody can access. Okay, so you should be very much secure. It should be overcoming AWS database migration challenge, good understanding of source database, planning time and resource in the migration. So firstly you have to understand completely about the source database. Why I'm saying the understanding is what type of application is connected with that. Okay, how you are using, how this source database is configured, what are the resources are there, is it this is hardware particular, for example it is running on power systems, they have the different CPU cycles are there. Okay, than the normal Intel. So you have to understand all the prospect of the source database. Then you can plan, okay, if I'm moving into the AWS, how much CPU memory I required. Then you have to do the planning time and resources in the migration. So you have to plan your time and um, when it will happen. Firstly, we will do the POCs, how much data will be migrated and what the resources we will use in the migration. Better understanding the network. This is very important because when it is migrating from your company to AWS, okay, this pipeline, okay, I will say why I'm saying this pipeline because it looks like, but this will be go over the network there. This network connectivity is very much important role will play here. If this network connectivity from cloud to your company, it is not very high bandwidth, and you started the migration full-fledged, or you started copying the data from your database to AWS database, it will choke your network. So you should be very much aligned with the network team and keep on asking, okay, how much bandwidth is free every day? Which time less traffic is there? Based on that, you can plan your migration. Better knowledge of exact requirements. Definitely requirement gathering session is very important. You have to, all the checklists you should have, like what is source, where you have to go, what is the schema, what are the different challenges are there. So you, if you once you have all the requirements, then go for the next. Next is schema conversion tool to be used if heterogeneous database migration are possible. For example, now what is the heterogeneous? Heterogeneous is when the change of database. So sometimes it's very simple. We will do the both the migration. So one migration where you have the MySQL database and you are converting MySQL to MySQL. That is the homogeneous. Same. database. MySQL to MySQL, Postgres to Postgres, Oracle to Oracle. That is no problem. No schema conversion is required. But when you are changing, for example, Oracle to Postgres or Postgres to MySQL, MySQL to Postgres, in those cases, you need this, okay, schema conversion tool. Now, how you will plan of your database migration? So in the plan of the database migration, why do you prefer one target database engine over the existing existing engine over the for example, why you are choosing Oracle in place of PostgreSQL? So any particular, sorry. So just a second. Okay. So you have to understand both why you are preferring and why you are telling. So if AWS is going there and okay, team, just give me a second. One call is coming and they mention urgent. Just give me a second. Okay, so we were on. Okay, we were talking about the planning. So firstly, if I'm from the AWS, okay, and I'm coming to your company and asking you, okay, so what your current database, and you're telling me, okay, we are using MySQL, then I'm that person who will convince where you should go. For example, I will tell you, okay, you should go to only MySQL, only MySQL to MySQL, or I'm suggesting you go to MySQL to PostgreSQL. Now, why I will convince you or why you will convince on that? Because I will ask you your existing issues. Whenever you will also go anytime in the for the solutioning, first question is what is your existing problems? And if somebody is saying, I don't have any problem, my application is working fantastic, no query problem, no response time, performance issue, nothing, then why I need to change? Then it is very difficult to convince to any client if they don't have facing any problem, right? But if they are saying, okay, our reporting is delayed, our application sometimes response time is very, query time is very means very high, and it is sometimes it's timeout. So in such cases, you have to find out, okay, and you will help to your client to understand why this problem is coming. For that, you should be a database expert, okay, and then you can only convince. Second type of approach is when you are going to the client and client already decided that we will go to the AWS. Some clients has very good team within their company. They already decided to explore that, and okay, AWS is good and we won't want to migrate on this database. Then your work is more easy because client will tell you we already tested or we already finalized, go here. Then you can give additional comment, and you can only judge their decision if you feel that is wrong or they should do something better that you can provide them. Okay. So second is, do you need your source database to be available after migration? That is the second point. Why this is there? You need to know they want the hybrid. They want only, sometimes companies saying they want to use only AWS for the DR. They want to just keep it the data there so that in case of DR, it is my database will be on the cloud and I will use there from there as well. But is it source will be remain there, like their main application will still work on prem, or only that is the one time migration and done, and then the application also move? So you have to understand that. Does this database need to be highly available? Now, definitely production, whenever you move, it should be highly available, but you will check. Sometimes company is saying, okay, it is development database, only backup is fine. If we lose also some data here, it's okay because it is just used for the development. Like every application has a development environment, testing environment, pre-prod environment, UAT environment, like names are different, but they have. Okay. Does all the data need to be migrated? This is another big question. Why you want all the data and why you not want all the data? Not want is simple. Sometimes people are just testing onto the cloud. They don't want to, they have the 4 terabyte. They will say, okay, you test it on the 1 terabyte and show me the results. Then I will think about the all the migration. Second, they don't want into all the data, they will not migrate if some of the databases are not in use or might be they are not required now. Some companies they have the like some old databases which they are not using. One of the company we are talking about, they have the asset management into there. Then they use the different tool, but still they have the older database are there. And then people are deciding, discussing with them what is this database. Then they told we don't require that. So you can remove such databases because bandwidth cost will be involved in that. Second, uh, okay, migrated to the SME database. Subject matter expert databases like where you are moving. Do you understanding the limits of using Amazon RDS, storage size, admin user, etc. Now, you have to very much understand this thing. Where you are moving, you know what is the complexity, what is the limits are there, what is the highest or lowest charges or your limits on in terms of resources, how much big a resource you can get. Like earlier, AWS cloud maximum was 96 CPU and I think 700. Firstly, it was the 500 something, then 700 something GB RAM. But if you need more, right? Is it available there? That you have to keep on, firstly check. What is your contingency plan if migration is unsuccessful? Means if your data didn't, so then how rollback plan or how you will continue your service or how it will work. So that plan is in your hand. Yes, if migration failed or didn't work as expected, what will happen? Can we migrate all the data back or all the data back? It will work from there. That mm, decision you have to take. Then implementation of the database migration. Any question till now? Sanjeev GP? No, you have to build that. You have to build that. Who is the database migration engineer or architect? He will prepare that. If migration is failing, because he's the migration expert. If it is a local, then they have the plan. Okay, but if the migration is failing, and then how you will continue from there? Okay. Okay, next is implementation database migration. The define first, never go with the production any time. So you have to define a proof of concept. Okay, so proof of concept will tell you will it work or not. Have you did any proof of concept any time in life, and what you did in that? Can you little bit give me details?
It's just like to test whatever the scenario is or whatever you're trying to do to make sure it's gonna work.
Okay, okay. That is generally every see proof of concept generally even I am also doing in my company. For example, even for everything, generally this is now people are saying MVP plan as well. these days. Proof of concept generally to showcase, yes, this concept will work. Whatever we are doing, yes, we can do. But the minimum things, right? So minimum database, one small database, and then it will work. So that way. So firstly, define a proof of concept. Which object do I want to migrate? Now you will find out, okay, this database I will migrate. Are my data types compatible? Means when you're giving all the data types like integer, uh, strings, other things, all the database, some has their custom or different data types are there, which you are might be not using. So in that case, you have to do manually. So you should aware of that. What is my target and how should I configure it to get required or desired capacity? So means definitely you have to check. So source, how much, for example, source is running on uh, 96 CPUs and 256 GB RAM or 512 GB RAM. Some very big databases are there. So on such scenarios, so you have to target, yes, where I will migrate this. Then design the migration. What is the migration scope? Complete designing will happen. Okay, I will use this tool, and then I will start the migration. So it will take this much time. So complete design should be there. Then is my source system configured to support a migration? So yours current, what is your system configuration are there? Is it migrated? It is ready to support it? And then why I'm saying this one? So sometimes I'm just talking about very generic, even your application migration. If your system is already 90% utilized and very highly utilized all the day, right? That time, will it support for the migration? Will it has the resources when the data will migrate, CPU will support, or it will crash in between, or it will might be hanged. So that things also you have to take care. Then prototype migration configuration and run the proof of concept. And then the client will definitely see and tell that, yes, it is good or bad, how it will work. Okay. That is the planning phase and how you should start. Now, how the AWS migration service works. Okay, so which is our major point. AWS database migration service, DMS. Migration data from on-prem to DB instance or database running on an EC2. Now, the migration is both sides, this thing. Even you can migrate or RDS. RDS is self-managed, right? AWS is managing about the RDS, right? You no need to install the operating system. You no need to patch the operating system. You no need to upgrade the database. You no need to manage the highly available database, standby database, read replicas creation. Everything is managed by the AWS. You just click, create it, use it. Migration then migrates NoSQL database as well as data warehouse. So DMS will migrate NoSQL database as well as data warehouse onto the Redshift as well because AWS is providing Redshift. They have the AWS SCT tool. SCT is schema conversion tool that translate the database. So which will translate the database schema platform and then AWS DMS can be used to migrate the data. So there is two things are there. Okay. So they are providing schema conversion tool. Now it will translate your existing schema and then migrate in the data to the new database as well. So DMS and AWS Snowball Edge integration enables mass database migration and migration of large database. So we in the data migration we talked about the AWS Snowball Edge. So where already it has CPU, memory, and from there it can integrate it with the cloud as well. So if you have a very large petabytes of data is there, then you are using even cloud Snowball Edge. Integrate both together, and because Edge has a storage as well. You can 100 terabyte data you can store itself there. AWS Migration Hub help you to keep track of progress of DB migration and also provide the key matrices. So when you have the migration hub. So there you can see and keep track of the progress. Means what's how much migration happened. This is database migrations are there. Also keep the key matrices. Okay, so you can keep on checking that. AWS migration service, same it is continuing. Start the migration in very less time. So you can plan and you can start very quickly. Keep the application running during the migration. So yeah, this is the one of the beauty. So when you start the migration might be not complete in a day. It can be take a week, 2 weeks. Your application can keep it there. Okay, it will be keep on running, and your migration will be continue. Replicates within to or from the EC2 or RDS. Now thing is, it's both side applicable. For example, some companies wants to go out of AWS. They are saying, okay, I want to move myself on Azure or Google Cloud or on-prem again. Might be any reason. Okay, so this can be used for both as well, in and out. Transfer database to the same or different database engines that we discuss about. So it can be transferred from MySQL to MySQL or MySQL to Postgres or Postgres to MySQL, like that also it's possible. Service related to AWS DMS, so main services and tools. Definitely one is RDS. RDS, all the relational databases are there. So there is Oracle, Postgres, Microsoft SQL, Aurora, and I think Oracle. That is their Redshift is there. That is the service which are used for data warehouse. Some companies has the big data warehouse solutions. So that if you want to migrate onto the Amazon Redshift, you can use that. Next is Amazon DynamoDB. So some companies has no SQL database, MongoDB or some any other database. If you want to move that particular or migrate that database onto the DynamoDB, you can use this. Then migration conversion tool, migration hub, you can use migration hub only use, or AWS migration hub only use for monitoring what's the migration is going on, where is it right now, how much is completed, how much is pending, so that you can see it. Okay, and formation, it is just for automation. How it is different, it is very quick and definitely secure as well. It needs minimum downtime. It support widely used database, actually widely used. It is the major databases it's all used. Still it is not using the DB2 IBM database. It's not compatible with that. It supports both homogeneous and heterogeneous, and high availability it provide. Now, how it works. So we have to just understand how DMS works. So source database means it is take. Then there is a source endpoints. So source endpoint means where it will go. So there is a replication task in between. So replication task is like a both side it knows what is my source and what is my target, right? So it is sending, okay, come from this side, and like it is a intermediator. Okay, it's a agent taking the money from one side and giving to the other side. So it is the replication task is the same thing. It is taking the data from your source endpoint and sending the data to your target endpoints. Now your target endpoint can be your RDS Aurora, it can be RDS your MySQL or PostgreSQL, it can be anything, and source it can be anything. Now database migration to AWS, three stages. The first stage is pre-migration, then during the migration, and then post migration. These three things are actually it is common for all the migrations you should. So what you have to do pre-migration, and then during the migration what you have to steps you have to follow, and post migration what you thinks, right? So generally in the first stage you will talk about how like pre-migration, which we discuss about. You have to identify and prioritizing database for migration. Now, for example, company has many applications, many databases are there. Now, which one you want to choose first? Okay, you have to think about, okay, this I will choose first, like web. This is web application is using to search, and there is a database. Now if I'm talking this one, you will prioritize that yes, no, this is more important, or this is the less important. Based on that you will select and you will start migration. Then you will running the SAT tool. SAT is schema conversion tool for heterogeneous DB migration. So what do you have to do in that? So you have to install that tool, create a project, connect to your source and target databases. So both databases you have to connect with this tool. Then view the assessment report, understand the complexity of database migration. So schema conversion tool, it will give you the report. Okay, these things I can convert, this thing I can't convert. So everything it will mention there. So it will convert your source schema to target, and then you can just apply the target schema to target database. So that's all. So once your schema is there, then you can migrate the data. So data migration to stage two. Now database migration not started. So you have see, okay, schema is done. Now you have to start. Run SCT in case of heterogeneous environment. Second, configure DMS for database migration. Then you initiate the database migration task. And last, you can monitor it, all the database migration onto the migration hub. And stage three, what you will do, firstly, you validate all the data has been migrated. That is the always post migration, whatever the application migration, you always check that it is everything is done. Perform all the post migration activity. What is the post migration activities? You test it. It is connected with your application. Query time is fine. You will already create like 10 queries. I will test all these 10 queries, and if it is my performance time is less than this milliseconds, so it means things are good. So the migration is successful. Then integrate your data center with other AWS services. If you want to like monitoring, you want to use the cloud services or any cloud watch or any other things that you can integrate, and apply AWS architecture framework to further optimize your database in the cloud. Now, you have once the database is migrate, there is a still scope of um, optimize that your database, how much performance optimization, and you have a different parameters are there which you can change it for the migration. Okay, after the migration of database for better performance, so that uh, you can change it. Okay, so we can take a break here. Just hold a second. Everyone, let me see if my tea is ready. Okay, so we will start our next part. So today we will complete the theory, and tomorrow we will start our both the practicals, monolithic and means homogeneous and heterogeneous environment. Okay, database migration with the AWS DMS. You will start the database migration with AWS migration service. Definitely you will use that DMS service. You will create a replication instance, so means who will be responsible for migration. Okay, so like a intermediate which we discussed about, you will create that first. Then you specify, third step is specify source and target. Now what is happening? So you have a intermediator here like this DMS. So this you will create, then you will tell, okay, this is the source and this is your destination. Now these two are the called the source endpoints and destination endpoints, and this you will create. Now here it is mentioning the same thing. So you specify the source and you specify the target endpoints. Then create the task. What is the task to create? The migration part. So from here to here, the migration will start. That you may create a task, then monitor this task. Okay, how much it is completed, taking how much time, and then you will definitely document and validate the steps. Yes, it is working fine. Any problem? So post migration task. So there is many use cases. So modernization is one. Why people wants to go this migration modernization? You might find the business or technical teams have made a commitment to modernize the framework or platform used in your application portfolio. Their may also be desired for standardization of tools to better integrate and engage with partners and customers. So the thing is, your company has always has some plans for their applications. Same application is running 5 years before, 10 years before, and now they are keep on changing. Every couple of years they were changing. Like even you can see the Salesforce, ServiceNow, they keep on modernize their application based on the new features to make it perform good, right? More and more older application or more and more widely used application, it's more difficult to modernize. But to make it modernize, for example, I will give you the simple example. In one of the healthcare company, what they are doing, so they have the application, okay? Application. This application is talking with the database. Now it was the monolithic application. Like everything is running over here and this is connected with the database. All the queries are coming onto this GUI and it is taking from database and it's working fine. But as the scaling happened, there is a limit. This application scaled. So then they move this application into the small parts. For example, this is the payment application. This is the cart application. So that has a registration application, like first time registered user. Okay. Then there is a OPD application. So multiple applications are there. Now in the modernized of application, what they did, so for each is created a separate database like this. Each service will talk to a separate database which is only used for their work. And this application, for example, when you add into the cart, it will talk to the payment. Payment, it will store the information here. So this is called the modernization of application. Now, rather than use one database, they use multiple databases. Now, the benefit of this, they got it. The query time was very fast, and they no need one big database like Oracle because where hundred of queries happening per second. Because in this application, same time payment application will send the query on the other side, user is registering, that is writing the data here, another cart is happening and that is storing here. So multiple things are happening. Now here it is on to the separate databases. So it will ease your work, manageability is easy, you don't need the high end databases for that. Then reduce the license cost. So how it will reduce, because you know Oracle is very costly database system, right? So there is many other databases are like Microsoft is there, IBM database is there, right? So if you are using open source like Postgres or MySQL, you may have an interest within the database to migrate an open source engine to reduce licensing costs. Scaling up of the infrastructure can be costly. So rather than keeping one database, you keep multiple open source engine and small databases, which will ease your work. And it will, if it is failing as well, only one database is the problem. Okay, not everything. So that is reduce your a lot of cost. Then you build on the proof of concept, showcase yes how it works, trail or export a proof of concept to see whether a database migration is possible, or highlight any gaps consideration that they may have to around the transactional code or unsupported data types. So you have to check that yes, if there is any unsupported data types are there which you are not using earlier, and now and they are, they configured custom for particular things in application, and later on you have to migrate. So you have to see there. Now, what are the AWS relational database services? So number one is web service that make it easier to set up, operate, scale a relational database in the cloud. So different type of, they are efficient and resizable capacity in the relational database. The thing is, if you using the RDS, Many people never use RDS, but I hope so you know about that. So one is very easy in RDS, manageability. Means if you want to increase CPU, increase the database, you no need to do take a big steps there. Everything is configured with the GUI. You go there, log in there, click on your database and make the changes. It's very easy. Backup. You want to take the backup, you just click over there every day, just mention the time, this time backup will happen, it's happen. You no need to go there every day and take the backup like earlier needs to be happen. Definitely, it's cost efficient and resizable capacity in relational database. Now, what is the cost effectiveness? Because you are not using licensed one. Sometimes, like Oracle, if you're not using Oracle, you can save a lot of cost with the use of open source databases like MySQL, PostgreSQL, and even you are using Aurora, that is the AWS database, okay, that is also based on the MySQL and Postgres. They are giving you some additional features and they're saying performance of the Aurora is 5 times more than the open source MySQL or PostgreSQL. Okay, so those things you will get it from the AWS itself, or AWS, you are paying to AWS and get the support from the AWS on that. Then you can want to set up the database, patching, backups, everything is very easy. Then provides better performance, high availability, security, and compatibility for databases. What is the provide the better performance? So better performance means when you're using this RDS, who, okay, better performance. I will not 100% saying it is always better, but as you seen earlier, they are saying they are matching with the Oracle 80 to 90% queries. But if you are comparing with open source MySQL or open source PostgreSQL, definitely RDS will give you the better performance. They already prove that yes, their database Aurora MySQL, it is based on MySQL on Aurora, it will be the 3x faster than the normal MySQL. And PostgreSQL is 5 times more, means you will get throughput there onto the RDS. And it is definitely secure and compatible with many other databases as well, RDS. These are the RDS, hope so you know. So Aurora, when they are talking about 5x faster than the RDS MySQL and 3x faster than the normal, actually it is the open source Postgres rather than RDS. MySQL, this is there is a Aurora as well and MySQL as well. You can choose MySQL. There is a that is completely open source, no support, nothing is there. But you are means you are paying for only for resources, CPU, memory, and other storage. Then PostgreSQL, Microsoft SQL, Oracle, and MariaDB as well available. MariaDB, MySQL, and PostgreSQL, all three are the means they all three are the open source. What is the advantage of RDS? The first is customized performance queries. Actually, this is from where I start. Okay, first thing I will take from right hand side, I will start. Customize the performance. Like some data, for example, in your company, there is a 10 databases are there. Okay, like every database into the under one umbrella, and some need more CPU, some need less CPU, definitely, because one application has a huge read and write happening. So there is database size is more. You need more CPU, more memory to support that. Another is need the less memory. It is a development application, internal use. It is very so based on that you can change. If you're, for example, you can customize your performance, right? You change the CPU for the different databases. I am integration. So now you have to who will manage, who has the access on RDS. You can manage it through identity access management. You will create a role, you can create the users, assign that particular permission, who can use that. Enhance monitoring. So Enhanced monitoring, it will give you the detailed about the performance of your database. Every 60 seconds also it will provide you. 5 minutes by default it isn't, but if you enhance it, it will provide you every 60 seconds what's happening there. High availability, with a single click, you will get a high available database, right? So you will just click on one parameter when you create the database and just mention, yes, it is done. And so, have you created RDS earlier? Anybody? Anytime?
Yeah, during training only.
Okay. GP, you created earlier?
Yeah, I did.
Okay, then it is fine. If you did, that is good. Then automated backup. You mentioned during the creation what time you want to take the backup. So you mentioned it is midnight, 1 o'clock. So 1 o'clock automatically backup will start. And read replicas. This is very important. If you know, it's good. If you don't know, read replicas generally, for example, your application is there. Okay. So many places when you, for example, this is a application, my orders. When it is my orders, okay, it will go to the database and only read the data. Okay, only read the data, whatever is there. Now, the because in my orders it will just go and check whatever the current my orders are pending. Okay, my last orders or all these things, it will be here in this database. Now, if it is a one database, I will talk about not the like this. Now, this is my main database. Rather than this application query to here all the time and read and write happening continuously here, okay, I will create a read replica, this one. Okay, I will mention here, this is my read replica. So read replica, how it works, it's a read-only database here. Now, only for the reads, this application, when somebody is asking, click over here, my records, okay, come on to this particular tab, it will go to this. In the application, you will mention this database name and it will go and pick the records from here and give the data to the user. It will not come here. When the user will go for any other application, for example, it is go for the payment. Then for the write operations, I will just mention here, write operations, it will come to the main database. Okay, so it will write the here. Same way, you can create multiple read replicas. Five generate support the 5 read replicas. So all the read operations you can change into the read replicas, or all the write operations you will move to the main database for the writing the data here. Okay, that is the benefit. The performance will automatically increased because definitely you have the you have the main database is here that will only use for writing, and querying will be here only. Okay, that is the read replicas. Then non-relational database where we are using DynamoDB here in AWS. DynamoDB is a NoSQL database managed service provided by AWS. So many companies are NoSQL database these days. What is NoSQL? Actually, unstructured data where you don't know what is your structure. For example, you are writing the address, pin code, complete address you are giving. So there is not mention, it is not storing into the any rational database. It is unstructured data, your IoT devices, their continuously logs are coming, unstructured data. So that they move into the DynamoDB. High performance database utilizing a variety of database data models, including document, graph, key values. Okay. So tagging, generally we are giving in the tags, that is the key value database. These are used into the DynamoDB, recognized for ease of development, highly scalable, high availability and resilience. See here, you're not creating anything like instance and create it. DynamoDB is table is work this way. it has a multiple system in the background. Okay, if you know, let me share with you. So how the DynamoDB generally works. So it has a multiple systems in the background like this. Physical or virtual system doesn't matter. Top of this, there is a new layer of the database. Like this is the table which will be deployed on multiple systems. This is your DynamoDB table. Now, this is running on multiple systems, so performance is really high because it is using the CPU memory from all these underlying physical resources. That is the reason it is giving a single digit millisecond latency at any scale. Now, whatever the data it's coming, how much size it is, doesn't matter. It always give you, because in the back end, this table is automatically adding the new resources in the background. Okay. So based on that, it will give you a very, very high performance database it is. So what is the benefit? It is also fully managed. Fully managed means you no need to do any installation, you no need to do any patching, you no need to do any OS upgrade, nothing. You no need to worry about. AWS is managing. You are just means using this database. Second is event driven programming. Now, what is the event driven? Like many places, there is happening. For example, there is, if any change happened, then write into the database. Any event happened. If something happened on your instance, it will go and add into the database. Okay, then yeah, highly scalable means if you your table is keep on increasing, so you can it can be very means up to, I think, thousand of nodes it can be added. Okay, it can be scale up to that. It's very flexible and fast consistent performance. Because of why consistent? Because throughout that time it is keep on increasing. Okay, in your, and it will keep your query time will be always in the milliseconds. That is the DynamoDB use case user profile, so which is just showing if a advertisement company is there, how it is storing the data, database profiling it is there. Okay, there is a high level higher onto the, we are not touch this part. Redshift overview. Redshift is used for the data warehouse. Okay, so companies, many companies are using data. Large data is there. Now, large data, which is I am talking about, um, companies like Walmart, Future Group, where has a thousand of stores around the world, millions of things are there in their data warehouse, right? Such things, many plants are there where is a huge data is there. One of the, like a plant where per second billions of um, data is coming, billions of records. Now, what is the billion of records? It means it can become from the IoT, it can become from the different sensors. Like many nuclear plants, there is a lot of sensors are there. Now, that sensor will give you the continuous data about your all the devices, thermal plants, what's happening inside, if there is any sudden temperature increase or decrease. So such huge data is there, then you are using the Redshift. Fast and fully managed data warehouse that provides simple and cost-effective service to analyze large data. Charges are less than a tenth of cost of traditional solution. Why the cost is less? It is the major reason to cost is less. This you can only use it when it is really required. For example, some companies has the weekly reporting system or daily reporting system in the night. So Redshift, you no need to keep it up and running all the time. You can create at that particular time and then use it, or keep it shut down and only start in the night. It will take, for example, 6 hours to generate the reports because data is too big. So run complex analytics queries against petabytes of the structured data using sophisticated query optimization. So when you have the petabytes of the data is there, right? So to query it and get the results, it will take a lot of time. Reporting will take a lot of time. So Redshift benefit, it is very fast, inexpensive, like one tenth of cost from the traditional warehouse solution. When they calculate, they will calculate everything, like 4 years of your um, hardware cost, right? For example, your hardware, that hardware is cost you almost 500,000. In 500,000, 4 years, how much is the cost? Then software cost, then people cost, then manageability cost. Mm, um, your in your company, that is what is the electricity cost, cooling system cost. If you calculate everything with the cloud, it is one tenth. It is secure, it has the keys encrypted, every information will be encrypted. It is extensible, you can extend it based on the scaling, so you can use them during the creation. It is scalable and it is compatible with many other services which you can use. It can upload the data on S3 and other services. Database migration types. So we will have the two major types which we are going to talk about: homogeneous and heterogeneous. So we discuss about source and destination have same database, MySQL to MySQL, Postgres to PostgreSQL. So we will call it homogeneous migration. So where you will take from the source side and migrate into the destination side easily. So that we will do the demo one on homogeneous. Then we will talk about the heterogeneous. So demo we will start because it will take time. So I think it will not complete today. So we will do it tomorrow, both. So heterogeneous is the, for example, which we discussed earlier, if databases change. So MySQL to Oracle, Oracle to MySQL, so like that. So MySQL to Aurora DB, so that is different. So you have to use same thing which we discussed earlier. You have to use firstly SCT, schema conversion tool, because two database has two different schemas. So you will use this. So you will convert the existing database schema from one engine to another first, then convert the source database schema to a format compatible with the target database, that it will convert it, mark the object that can't be convert so that they can be manually migrated. So if any project object, you can see um, it is not converted because that tool can't convert it, is a customize or any other reason, you have to manually do that. Then scan the application source code for embedded SQL statements or convert them into the part of DB conversion, schema conversion project. And then source database can be anywhere. It can be on on-prem RDS, EC2, and it can be migrated to any other place, RDS or EC2. Okay, database migration from source to target. So you can use any one of this database. Okay, Postgres, MariaDB, Microsoft SQL, but other databases are not supported. Many databases, like if somebody is saying, I have the MongoDB, can you migrate? No, it is not mentioned right now here. If there's some IBM DB2, okay, no, we can't support that. Now, this is a support conversion, like source, what is the source database and what is the target? For example, if your source database is Greenplum database. Now, how you can use it? You can only target can be Redshift, nothing else. So that can't be moved to the MySQL, can't be moved into the another. Microsoft SQL Server, it can be moved to the Redshift. Okay, Oracle to Redshift. So these are the source and destination, Vertica, okay, Teradata you can use. Now there is a OLTP conversion using ST. So MySQL can be converted into these three. MySQL, Microsoft can be converted into the MySQL, Postgres SQL, and MariaDB and Microsoft to Microsoft SQL Server. That is also possible. MySQL version 5.5 and later can be migrated into the Aurora Postgres, MySQL Postgres. You can migrate schema and data from MySQL to Aurora MySQL DB without using AWS SCT. If it is like we talk about the homogeneous, if it is MySQL to MySQL, then you don't need SCT. Okay. Then Oracle. If you have the Oracle, Oracle can be migrated only in these three: Aurora, okay, MariaDB and MySQL, or definitely Oracle itself. PostgreSQL can convert it into the Aurora MySQL, PostgreSQL, okay. IBM DB, that is okay, and they have, I think it is came as well. Source, if it is micro, IBM, not DB2, LUW, they have different. So you can use MySQL, Postgres, and that is also converted. Apache Cassandra, it can move only into the DynamoDB. Sybase, okay, Sybase can be converted into these. So this is the conversion matrix they have given. How it is working together? So DMS and SCT. So first step, what is doing? You are using schema conversion tool. Tomorrow we will use that. We will deploy in one place. That conversion tool will convert all the schema to the target. Then DMS migration service target, it will migrate the database. So first step, it is only migrating the schema. Second step, migrating the complete database. So SCT, how running SCT for the heterogeneous DB migration? You have to download that schema conversion tool from the AWS website. Download it. So and then mention the source database, what is their custom codes are there. Then install on one machine, on your machine, wherever you want, where it is interact with the source database. Then it will connect to the source database and run the schema conversion tool. There you will tell in this where you want to migrate. For example, you mention I want to migrate this MySQL to PostgreSQL. So source database, it will check and it will convert based on what you mention into the target. Okay. So do's and don'ts. Manage the migration of data from one database server to another. Create only those objects needed to perform and optimize migration of yours in heterogeneous environment. In the left right hand side, they mentioned heterogeneous environment, you can't directly migrate. You need the schema migration tool if you want to migrate anything. So you can does not manage to migrate of database schema, that is structure of your database. Target database need to be created first, and for the database migration service to work, it doesn't mean it will automatically create the database. No, you firstly create the database, then your migration service DMS will use source and destination to migrate it. Free AWS SCT can be used to migrate entire schema from one database to another database. So database migration best practices, loading multiple tables in parallel. So by default, AWS loads 8 tables at a time. So performance improvement can be seen by using a very large replication server such as DMS C4 X large. It depends upon how big is your migration. When you do a big database migration, such you need the more CPU and more memory, right, for the migration. So it depends upon which type of system you are using. If you are using T2 micro, for example, for the migration, it will hang, it will stuck, it will take a lot of time, it can be failed, right? And second thing, you can do disable all your backups and transaction logging. For example, if you when the migration on RDS, you better to disable it. Okay, backups, because backup will take a lot of resources. Okay, it's consume a lot of resources. And then even if it is a logs are generating, sometimes what happened if your team started logs, okay, all the transaction logs, it will generating huge every seconds, thousands of logs are created, it depend upon. And then that transaction logs are very important as well. So depend during the migration or time, you can even disable that so that migration will be smooth. Otherwise, a lot of resources will be used there itself. Then reducing the load onto the source server. Number of tasks or tables for each task can be reduced for migration. Each task gets source changes independently, so consolidate tasks can decrease the change capture workload. So generally what happened, so onto you want to reduce the load onto the source, because when it is start migrating, same time it is using, okay, it's a problem. Generally what happened, In the companies as well, you have two databases, master and slave, or master or standby. So you do the migration from the standby rather than master database, because standby has all the same information but it is not in use. So you are starting from there, so that which are the standby database you can migrate from there. For example, in your company, you have definitely redundancies there. This is your primary database, primary, and this is your standby. In case of this failure, if this failure, automatically your this database will start standby. But now when you start the migration, you will start from here standby, because all the data is replicating to here. Whatever is here, it's replicating here. So you can start the when you start the migration, you will use this standby, because it is not continuously read and write happen. Only when the primary is something writing, because here in the primary might be the read is always happening, so here read will not happen. So a lot of CPU cycles are saved here. Okay. So enable the multi-AZ options. So multi-AZ is definitely required for the failover into when you're during the migration, or you are creating onto the other side. Okay. So that is multi-AZ, because in AWS, when you create your database, they are asking if it is multi-AZ, it will create automatically two database. One is in one availability zone, AZ1, and second database it will create multi-AZ, means second it will create in AZ2, so that if availability zone is down due to any reason, okay, other availability zone will be available. Okay.
It costs double, or
Yes,
it's
definitely it
probably
costs
more
double.
than the
It's cost
cost of
exactly double, because you have the two databases.
yeah.
But I think that's a mandatory configuration. I see the configuration a lot of places, primary and secondary.
You should have, if database is down, your company's major
Yes.
data will be on the stake. And
Hmm.
AWS is not saying, see, you can take the backup of this, then restoration time is more. If you want to, if it is a development database, I will say, okay, just take the backup. And if you can ready, for example, if it is down, okay, and your development team is saying, okay, we are okay if it is down for one day, you can within a day you can restore everything. Then you no need to for a standby. But it is always required for the production database. When your application is critical, your database is critical. For example, financial institutes, there is a company's internal database, for example, where your every payments are there, or your every company's employees data is there, right? Your salary structures, so wherein they will keep some database. If that database is down or corrupted, what will happen? Nothing. All every person's salary is gone. They don't have any data whose salary what, right?
You have to make a decision when you're creating the database. You cannot change it, or you
Yes.
can
During the
multi-AG like it.
yes, you can. You have to take the decision during creation itself. That's the
Okay,
reason
so
when you are migrating, you have to do the prioritize.
okay, but you cannot change to multi-AG after you've done doing everything. I don't know
Yes,
if
you
it's
can
possible.
modify and make it done.
Okay.
Yeah.
Yeah, the database is very expensive. Like I was looking the other day, the bill for our company, it was 70% cost was the databases.
Yes,
The 200
absolutely.
server running 180 server wasn't cost like 30%. 70% was the database cost, and it was
Absolutely.
$70,000 a month.
That is still less. I have seen there is a much more on that. Much more.
Yeah, it's our is a small company. I'm talking about maybe millions of dollars for the bigger company. Maybe, yeah.
Yes, because more big companies has the more on cost onto the database. And definitely they are spending a lot because of multiple things: query time, performance, their backup. Because you are not spending on one, you are spending actually everything double, minimum double. There is third backup, right? So this is you're on not only like this is primary and this is standby. There is third thing is backup as well. You are continuously taking the backup here. That is the third cost, right? So that's the
Yeah,
difference.
I mean, the structure for one thing is very, very confusing in AWS is the price structure. You pay
Ah,
one cost for just doing it, and then the query cost is IHOP cost. It's just added into it's very complicated, even to EC2 instance stuff and S3 bucket. It's there are a lot of costs add into it because it's just not like one thing you're just paying for it.
yes, absolutely. It is not for one thing you're paying for. It looks like one, but they are telling you the different stories, right? So they will say internally also you are not paying for one. Actually, it is the multiple.
And then multiple, then you pay for the space,
Yes, you
and you
internal
pay
also
for
you are paying
CPU.
for. You will not come to know. For example,
Yeah.
in the internal you are paying for the physical hardware. Okay, so this is the physical hardware. In the physical hardware, this is attached with another storage, like outside storage, right? This is the where all your data is there, database, or you can say other transaction logs, everything is storing here. Then this physical server might be the database is stored inside. For example, I'm just taking this is the database, it is storing here DB, and this is storing not onto the local disk, it is generally onto the SAN storage, right? For SAN storage connectivity with this, it has the SAN switches, then backend storage is there. Then for this, there is a backup also outside. There is you are taking the backup of SAN storage as well, because if this storage gone, then what will happen? There also you have the backup, and there is also SAN. Another solution is there, like redundancy everywhere, database redundancy will be there. So internally, and then they will say you are not only paying this, this is it just you can see from outside. More than that, you need 24 by 7 support, right? You need the people to upgrade the SAN switches, you upgrade the your OS, upgrade your storage, upgrade everything, it is there, and you need the team. But in AWS RDS, you no need to do anything, right? Everything AWS is managing. Second, for this you are paying onto your data center, electricity cost, cooling cost, and other things are there. UPS here nothing. So they calculate everything in that during when they are explaining to you.
Yeah, but there's also option in the RDS too. If you pick up that what size of instance you want, how much space CPUs they have, you large,
Based on
extra large.
charging are there.
Okay.
Based on the
Yeah,
charging are there. Because if you're
yeah.
using large
And then
instance, big large, charges are different.
different, and then you have IHOP if you need more IHOP for the database. That's extra cost for it. Um, in this, yeah. I think that a read only if you need the caching one. Yeah, it just
Yes,
is
everything,
adds up.
everything. If you need, it is a different cost is there. So generally, databases has the caching solution in front of that, right? So caching solution is the different charges for AWS. That is the separate service.
Yeah,
And second thing, they know even you are coming once, it is very difficult to go out because here everything is on the click. If
correct.
in your company, if you want to create, build a new database and replicate with another location, you need a lot of efforts. Like it will to order the hardware, get the planning, replication, everything. It will take months of time, 3 to 6 months. But here, create a database, replication, redundancy. within a single click you will get it. Like within first 5 minutes you create the database and it will start replication as well, and you can start using within 5 minutes, right? So major why people are going on the cloud, it's I can't say it is a cost effective, because cost definitely longer run cost is high on cloud. Okay, only the benefit is you are ready to means go to market is very fast. Okay. For example, these days very competitive world. If you think about SAP or GE, competitors are there. SAP and IBM is also competitor, some of the solutioning, right? Now both wants to build a new product for the companies, some ERP solution everybody wants to build. Somebody started in their company and they have DevOps pipeline, everything is required for the faster. Here, to build the DevOps pipeline is just one click. There you have to tell to the DevOps team, okay, build a pipeline for us. They will take might be a week time. But here, with a click, you will create it. Then you will ask, okay, create this database, all other things. Within 3 months, your setup will be ready, 3 to 4 months. But in mean 3 to 4 months, another company can even start their application to their customers, because your infrastructure will be ready within less than a week, right? So who will go into the market first? They will definitely capture the market first. They have the more users or more clients are there. That is the race right now. Not only the see cost you can recover with your product cost, right? But if you delay in the feature, for example, I will tell you Uber and Ola in India. Ola is coming with the more and more solutions. For example, Ola started the autos first, then Uber started, right? So it might be both started together, but it depends upon how faster your company internal processes, right? Who can go in the market first. So that depends. So market capture is very much important sometimes. Okay, so any other question?
No, I'm good. Thank you.
So tomorrow what we will do, we will do this both the demos, homogeneous and heterogeneous. Okay? Okay guys, we'll meet tomorrow at same
Okay.
time.
Thank you.
Thank you.
Thanks. Bye bye.
Yeah, thank you. Bye.